So we are on notes section 6.1. The title is Operations on Functions. So from semester 1, we should already know that functions like f of x or g of x, we should know that these guys are just the names of the machine, right? And this is called function notation. When I tell you find g of 3, it's really an easy way, an easy notation of saying go to your g of x function and plug in the number 3. Right here it says go to your f of x function and plug in the number negative 3. Okay, so this is just notation. It's a quick way of saying to plug in 3 into your g function, plug in negative 3 into your f function. So if we do number 1, what would I get as an answer? Anybody? Let's actually work this out. So again, g of 3 is saying go to your g function, which is this guy. It's the negative 4x plus 2. I would rewrite it. Negative 4x plus 2. Notice that I didn't put an x, I put parentheses. Why is that? Because it's not a g of x, it's not g of x, it's now g of 3, which means we're going to plug in a 3 into the x position. That's why I put parentheses there, so I could actually plug in the 3. I'm going to plug it right in there. So g of 3 equals negative 4 times 3 plus 2. Negative 4 times 3 is negative 12, and negative 12 plus 2 is that negative 10. So we were correct right there. G of 3 is negative 10. How about f of negative 3? What's that answer?
9.
9? Anybody agree with that? Has anybody done it? Go ahead, take your time, do it. Let's actually show our work on number 2. Again, this is saying go to your f of x function and plug in negative 3. Here's my f of x function. I'm going to rewrite it, but instead of the x, I want to put parentheses. So I have 2x squared minus 7. And inside of the parentheses, I'm going to replace the x with the negative 3. And of course, right here, we have 3 operations. We have multiplication, 2 times, and then we have exponents on the negative 3, and we have subtraction. Out of those 3 operations, we do exponents first. So when I go negative 3 in parentheses squared, that's really negative 3 times negative 3, which is positive 9. So I have 2 times positive 9 minus 7. And 2 times 9 is 18, and 18 minus 7 is 11. So those are our 2 answers to this, I guess we could call it a class opener. You guys should have copied this down in your notebooks. Let's get to the real notes, operations with or on functions. So we're going to do operations with these functions, f of x and g of x, and h of x and r of x, and all these other different named functions. This is our book right here. You guys don't have the book in front of you, but this is a picture straight from page 385. And we're going to be doing operations with these functions. Not necessarily, I mean, sometimes we will be plugging in numbers and working them out, but sometimes we're just going to be adding 2 different functions together, or subtracting or multiplying or dividing. So we have a table right here on this page, and they're using the f of x function, which in this case is 2x, and the g of x function, which in this case is negative x plus 5. So you have your 2 functions there, and we're going to have to add them. And this is the notation that you're going to see. They're going to tell you to do that right there. So it's saying the f function plus the g of x function. So you're going to take the f function, whatever it is, and add it with the g of x function. There's the f of x added with the g of x. So what is the f of x? We said the f of x was 2x, and the g of x was negative, the binomial negative x plus 5. So what they want you to do is add the f of x with the g of x. So there's the 2x, there's the f of x. Here's the negative x plus 5, the g of x, and we are adding them together. And that's really just combining like terms. So your answer is x plus 5. Okay. So they're going to ask us to add, to subtract. This is just the notation, right? This is adding notation. And you know what? To be honest with you, most of the time I will not write it like this. If I want you to add f of x with g of x, I'll actually just write it like that. F of x plus g of x. And all you do is plug in f of x, plug in g of x, and combine like terms. Now, if there's a minus sign, when you plug them in, you're going to have your f of x, which is 2x. There's a minus sign. Here's your g of x. You're going to have to distribute that minus sign before you combine like terms. Here's a notation that you might see, f times g of x. F times g of x. What does that mean? Take your f of x function and multiply it with your g of x function. So that really just becomes the f of x function, 2x, times the g of x function, which is a binomial negative x plus 5. What are we going to end up doing here? Distributing, right? So you just take that 2x, that'll be a negative 2x squared, and that'll be a positive 10x. So that's why the answer is negative 2x squared plus 10x. And we're also going to be dividing, right? You might see this notation, f divided by g of x. That's just saying get your f of x function and divide it by your g of x function. And of course, in this case, you end up with a fraction. You can't really do anything. You can't cancel anything out. Sometimes when we get to more fun functions, you might have like a quadratic trinomial and a quadratic trinomial. You might be able to factor it and then cancel things out. But right now, you just plug it in, and if there's nothing to do, then there's nothing to do. Whenever you do have a function that has a variable in the denominator, you want to find out what value would mess it up. So you could state that x cannot be that value. So obviously right here, x cannot be 5, because if you have a negative 5 plus 5, then it'd give you 0 in the denominator, and we know that that would be undefined. So we say x cannot be 5, okay? So we're going to be doing different operations with functions. I might ask you to add them, to subtract them. In the book, they give you examples. Obviously, we have f of x being x squared minus 4 and g of x being 2x plus 1. If they ask you to add them, simply add your f of x with your g of x. Plug in the f of x, plug in the g of x, put a plus sign between them, and then combine like terms and you get your answers. Pretty straightforward. So you have all these different examples in the book, page 385. If you go to page 386, you have another example. This is one of multiplying, where your f of x function is that quadratic trinomial, your g of x function is that binomial. They're showing multiplication, so you have to multiply your f of x with your g of x. There's your quadratic trinomial times your linear binomial. So you'd have to distribute, and then combine like terms, and you'll get your final answer, which is a cubic polynomial right here. So all these examples are in the book, and we will be doing some of this on our homework today. Now, the most interesting part of today's lesson, when we're doing different operations with these functions, is, where are we at? Let me see. When we end up with something like this. They give you an f of x function, 2a minus 5, and a g of x function, which is 4a. Now notice, this looks like a multiplication, but it's not. It's actually an open circle. This is called fog notation. Now, when you have an open circle, it's saying f of g of x. So this little circle, which most of the time I won't even use it, I'll use this. Okay. So normally we would say f of some number, right? If I said f of 5, what does that tell you to do? To plug in 5 into your f. So you put a 5 right here, you do the math, and you get your answer, right? Yes? Now, if you don't have a number, you actually have g of x. They want you to take your g of x function and actually plug it in to your f of x function. Okay? So again, if I had f of 5, all you would do is plug in a 5 right here and do the math. But you don't have a 5 right there. You have a g of x. So what do they want you to do? They want you to plug in g of x into your f of x function. They want you to take your g of x, right? Their g of x is 4a, and plug it into your f of x function. So you're going to end up with 2 times 4a and then minus 5. And that's exactly what it says here. 2 times 4a, then minus 5. Then, of course, 2 times 4a, that is 8a, and bring down the minus 5, and you're done. Okay, so all this is in the book. It'll all be on video as well. Let's get to the actual worksheet that we're doing for homework today. So the homework assignment, it's up on the wall on the back homework board, but we're doing 1 through 19 odd, but notice that the worksheet that I gave you has a lot of them missing. But you're doing the odd ones only that you have on your paper, okay? So we have 1, 2, 3, so we're doing 1 and 3, and then it skips to 8. So we're doing the odd ones only, but we're also doing a couple of even ones, 10, 16, and 18, all right? Anyway, numbers 1 and 3 is what we're doing. Let's do, what do you guys want me to do, number 1 or 3? Okay, I'll do number 1. Let's do number 1. Check it out. What do the instructions say? They want you to add f and g. They want you to add f of x and g of x. They want you to subtract f of x and g of x. And they want you to divide f of x and g of x. So they want you to do 3 problems in one right here. That's why we're doing the odd ones only. So let's add f of x with g of x. So you could write it as f plus g of x, or you could just actually write it out that you're going to add f of x plus g of x. I probably prefer this second one. But of course, like on the CASP test that you guys are going to be taking your junior year, you need to know this notation just in case they don't write it like this, they give it like this. So anyway, let's write down your f of x function, which is 2x plus 1, right? That's the f of x function, 2x plus 1. And let's add it with the g of x function, which is x minus 3, x minus 3. Now notice, because there's addition, I don't put this in parentheses because you don't have to distribute a plus sign. Distributing a plus sign would not change anything. So it's just straight up combining like terms. So what is 2x plus x? That is 3x. And what is 1 minus 3? That's just the minus 2. So there's your answer for f of x plus g of x. Now that's barely one of the 3 things they want you to do. That was f of x plus g of x. Let's do the next one, f of x minus g of x. Right? So let's write that out. F of x minus g of x. So what is f of x again? 2x plus 1. I'll put it in parentheses this time since we're going to have to distribute that minus sign. What's the g of x function? X minus 3, thank you. Okay, and you know what? That minus sign, I'll put it in black so it'll stand out. So what do we need to do here in order to simplify? Distribute. So let's go minus right there on the x, minus right there on the minus 3. So what we have now is 2x plus 1 minus x plus 3. Notice that there's nothing out here to distribute, so you don't even need the parentheses. I just wrote it 2x plus 1. The minus sign, you distributed it to both. You end up with a minus x and a plus 3. Now let's combine like terms. 2x combined with minus x, that just becomes a regular x. 1 combined with 3, that gives you a 4. So x plus 4 is the answer for f of x minus g of x. They also want us to multiply and divide these functions. So let's do this next one of multiplying f of x with g of x. So let's multiply the 2x plus 1 with the x minus 3. Since we're multiplying, you have to put them in parentheses. That way you'll remember to multiply. Let's distribute 2x times x, that's 2x squared. 2x times negative 3, that's negative 6x. 1 times x, that's another x. 1 times negative 3 is negative 3. Combine like terms, the middle terms, and you'll get a final answer of 2x squared minus 5x minus 3. So I do apologize with the lack of space. You might have to rewrite these questions in your notebook instead and show your work in your notebook. We still need one more thing to do. We've already added f and g. We've subtracted f and g. We already multiplied f and g. Now let's divide the f of x function by the g of x function. So to divide, I'll do this right here on the side. You could set it up. First of all, if you're able to divide, you might have to use long division or maybe synthetic division. But in this case, you can't really divide it. So let's just write it as a fraction. The top one would be the f of x function, 2x plus 1. And the bottom one is x minus 3. This says f of x divided by g of x. Now, this is the answer, but you have to put this. But what? But x cannot be what? X cannot be 3. Why not? Because if x is 3, 3 take away 3 is 0, which would make the whole thing be undefined, so that would mess it up. So your actual answer for the division problem is that fraction, but you have to also state that x cannot be 3. If you check the answers, I post the answers in the back of the worksheet, you should have all those 4 different answers, okay? Whoops. So there's obviously more to this homework. Okay, so on the second part, it's saying, I actually made a typo right here. It's saying to plug in your h into the g. This is saying that the h function goes inside of the g function. That's what that little symbol means. And over here I made a typo. I wrote it wrong. It should be where the g is on the outside, which it is, and the h should be on the inside. So it's h of x of g. Wait, is that how you say it? Yeah. G of h of x. That's how you say it. G of h of x. So whatever letter is second, that's what you're going to be plugging into the first one. So let's do that with number 8 right here. Since I did assign, oh no, I didn't. Did I? No. Number 10. Let's go to number 10. So we want to do both g of h of x and h of g of x. So let's write that down. G of h of x and also h of g of x. But let's start with g of h of x. So I'm going to plug in what into what? Help me out here. What does this notation mean?
H of x into g of x.
You're going to plug in the h of x into the g of x. And what is h of x really? 3x squared. Okay, so I really am going to be plugging in a 3x squared into my g of x function. So let's start by writing our g of x function, right? I'm going to plug in something into my g of x function. Let's start by writing our g of x function, but with parentheses. So we're going to go parenthesis plus 6. And what are we going to put inside those parentheses? We're plugging in the h of x, and h of x happens to be 3x squared. So that is going to go right in there, 3x squared. And there is no distribution. There is no combining like terms. There's nothing to do. So you don't even need the parentheses. So let's just write down our answer as g of h of x equals 3x squared plus 6. And now let's do the opposite one. Let's do h of g of x. Okay, so h of g of x. So what does that mean? That we're going to plug in the g of x function into the h of x function. So we're going to take the g of x function and plug it into the h of x function. So let's start by writing the h of x function. I want to write it as 3x squared, but instead of x I put parentheses because I'm going to plug in the g of x function right in there. And the g of x function really is x plus 6, so put it right in there. X plus 6, and then you do the math. Now on the other one we had no math to do. There was nothing to do. You couldn't distribute, you couldn't multiply, couldn't combine. But right here you actually have a binomial that's being squared. So you need to write that binomial 2 times. X plus 6 times x plus 6. And then after that, don't forget that you have to distribute the 3 that's on the outside. So let's first begin with the binomial times the binomial. So we're going to have x times x, that's x squared. X times 6, that's 6x. 6 times x is another 6x. And 6 times 6 is 36. Combine the middle terms, you'll get 12 of those x's. And we still need to distribute the 3 to get a final answer. So the final answer will be 3x squared plus 36x plus 108.
108.
Yep.
Oh, yeah.
So that's your answer, and you should always rewrite the notation that represents that answer, and the notation is h of g of x. That's what it equals. It equals 3x squared plus 36x plus 108. So it gets a little bit more challenging when you're not dealing with pure numbers, when you actually have variable expressions to plug into other functions. And down here, the last section of a homework, it's not that bad. They do have different functions, f of x, g of x, and h of x. And you need to know which one to use, and you begin working from the inside out. Okay, kind of like parentheses, you zoom in and you do whatever's inside. Right here you would plug in a 1, and where would you plug 1 into? Plug 1 into where?
5x.
Into the g of x function, into 5x, right? And then after you plug it into the g of x function, you're going to get an answer, and where do you plug that answer into? Into the f of x function. Yeah, which would be x squared. So which one would you guys like to do on this third section? We're doing the odd ones. Or 16 or 18?
16.
16? Sure, why not? So on 16, let's first remember that the f of x function, we're going to be using the f and the h. The f of x function is x squared, and the h of x function is x plus 4. Okay, so I zoomed in and I rewrote the function so we could have them right here without having to move the screen around. So again, we're going to work from the inside out. We have a 4 right here. Where are we going to plug in the 4? Into the f, right? So here's the f function. I'm going to put a 4 right in there. So if I do plug in a 4, what do I get? 16. And you could actually write that down. F of 4 will equal 4 squared, which is 16. Yay? So we all agree that f of 4 is really 16, right? So right here where it says f of 4, what am I going to put right there? 16. So I really have h of, you guys said, put a 16 right there. So now let's actually work out h of 16. Well, here's the h of x function. And what are we plugging in? We're plugging in a 16 right in there. So that's really going to be 16 plus 4, which equals 20. And again, what equals 20? The whole thing equals 20. The h of f of 4. Again, you plugged in 4 into your f function. You got an answer, which was 16. Then we plugged in 16 into our h function. We got an answer, which is 20. So that's all there is to it with this entire section. I want you guys to use the rest of the class to finish up this assignment and check your answers on the back as you go.